In this question, we can look at statement 1, the medians are equal, and that actually makes a lot of sense because we have evenly spaced out data. We have 1 here and 1 here, 4 here and 4 here, 2 here and 2 here, and so it makes sense that the median is going to be right at the 13. Similarly here, 2 and 2, 4 and 4, so everything is totally symmetrical, 2 and 2, and so it makes sense that the median is right here. So are the medians equal? Definitely they are. Now, looking at statement 2, let's talk about what standard deviation is. Let's imagine we have two data sets that both have the same average. They're both centered in the same way. They both also have the same range. So they start and end at the same places. But in data set A, the three remaining values are very spread outward, whereas in data set B, the remaining values are spread inward. So these two data sets have the same average, the same range, but they have different deviations. This is the idea of having more standard deviation, and this is the idea of having less standard deviation. And this is just the SAT, ACT sort of level that you need to know it at. Obviously, if you move on to higher levels of statistics, then you're going to have to know a lot more than this. In any case, which one has more standard deviation? In these two data sets that they gave us, the standard deviations are relatively equal because you've got values that look very similar going outward. However, just simply by virtue of having 2 on the outskirts here and 1 on the outskirts here, we know that they're not exactly equal. They're not spreading in the same exact way. So we cannot say with confidence that the standard deviations are equal. So we're going to go ahead and say that 1 is true, but 2 is not necessarily true.